Okay, now in his first question, the question states that a poll reported that 70% of adults were satisfied with the job the major airlines were doing and 30% were dissatisfied. Now suppose that 8 adults are selected at random and the number who are satisfied is recorded. Use the binomial distribution table to answer the following questions. The first question states that what are the values of n and then p? And the second sentence, since it's saying suppose that 8 adults are randomly selected, therefore n would equal 8. As far as p is concerned, the second sentence also states that the number who are satisfied is recorded. There are 70% of adults who were satisfied, 30% were dissatisfied, and since we're looking for the satisfied, therefore p is equal to 0.70. Now, the next question states that what is the probability of getting exactly 3 adults who are satisfied? So we're looking for the probability of 3 adults. And what we need to do is use the binomial distribution table to answer this question. So if we take a look at the next page, okay, here is the binomial distribution table. You have the value of n, you have the value of x, and then here are the binomial probabilities. Now, if we're looking at the value of n, scroll down a little further here, and then x is the number of trials, and we'll talk about that. And if you notice here, we're going to scroll all the way over to where you see 0.70 highlighted because that's the column that we want. So if we scroll down a little further, and you notice here that n is equal to 8, and then we're looking for exactly 3. Now, exactly 3 is going to be that percentage here. So therefore, if you look at that value, it says 0.047. So the answer for what is the probability of getting exactly 3 adults who are satisfied is 0.047. Now, if you move on to the next question, it's saying what is the probability of getting no more than 3 adults who are satisfied? So that means we're looking for the probability of all the values that are less than or equal to 3. So we're looking for the probability of exactly 0 plus the probability of exactly 1 plus the probability of exactly 2 plus the probability of exactly 3. Now we've already found that a probability of exactly 3 was in the previous question, which is 0.047. And then we need to add the other 3. So let's take a look at that. So again, looking at the chart, again, we're looking down the column of 0.70. We scroll down here. Now, if you look at 2, you got 0.010. If you look at 1, you got 0.001. And if you look at 0, you're looking at 0 plus, which means it's 0. So now if we go back and we take a look at the results, so the probability of a 0 is 000 plus the probability of 1, which is 0.001, plus the probability of 2, which is 0.010, and then adding the probability of 3 together gives you 0.0580. And again, that is the probability of getting no more than 3 adults who are satisfied. Now, if we take a look at the next question, it says, what is the probability of getting more than 3 adults who are satisfied? Well, more than 3 adults would then be x is greater than 3. And what we would do is we would use the complement rule. We would take 1 and then subtract the probability of x is less than or equal to 3. Now, since in the previous question we found that, we can take 1 and then subtract 0.058, which would then give us the result of 0.942. Now, the last question here is saying that if 25 adults are selected, use the binomial distribution probability formula to determine the probability of getting exactly 20 adults who are satisfied, and then round your answer to 3 decimal places. Now, in this last question, you need to use the formula in order to find this result. And the binomial probability formula is given by the following, where n is the number of trials, x is the number of successes among the n trials, p is a probability of success in any one trial, and q is a probability of failure in any one trial, meaning 1 minus p would then equal q. So in this question, it says if 25 adults are selected, therefore we can see that n is equal to 25. Okay, and then you're going to use the binomial distribution probability formula, which is this, to determine the probability of getting exactly 20. So therefore, x is going to equal 20. And then in the question, we know that the probability of success is 70%, and the complement, 1 minus 0.70, is 0.30. So now we have all the given information to plug into this formula. Now using this formula, we're finding the probability of exactly 20. So you have n, which is 25 factorial, over 25 minus 20, which represents x factorial, times x factorial, which is 20 factorial, times 0.70 to the 20th power, times 0.30 to the 25 minus 20 power. And then what you can do is you can just go ahead and then simplify. So by writing this all out, you got 20 factorial at the end. You also have a 20 factorial over here, so you can simplify that as 1. And then 25 minus 20 gives you 5 factorial. And then you can simplify these numbers to then get the following. 5 times 6 times 23 times 11 times 7 times 0.70 to the 20th power times 0.30 to the 5th power. And all of that gives you the probability of 0.103. And then remember that you're rounding this to 3 decimal places. Okay, the next question states that assume that students in 5 statistics classes have final exam scores that are normally distributed with a mean of 85 and a standard deviation of 10. And we want to find the probability that a randomly selected student has a final exam score between 70 and 100. Now, the first part of this question wants us to draw 2 normal curves, one over the other, where the top curve is for the x values and the bottom curves is for the z values. So if you look at the first curve, right, so you're drawing your curve, right? We know that the mean is 85, and then we know that the two scores that it's in between is 70 and 100, and we want to find the shaded area that's in red. Okay, now, in order for us to draw the second curve, we need to find the z-score for 70 and the z-score for 100. So before we put the values in for our curve underneath there, we need to find the z-score for 70. So using the formula for the z-score, we know that x is 70, we know the mean is 85, and the standard deviation is 10. So we take 70, subtract 85, divide it by 10, which gives us negative 15 over 10, which gives us a z-score of negative 1.50, and therefore this now represents negative 1.50. And now we're going to look for the z-score for x is equal to 100. So now x is 100. We're going to subtract the mean of 85 over 10. We get 15 over 10, which then gives us a z-score of 1.50. So now this curve now becomes the z-score and the normal distribution. So it has a mean of 0 and the z-scores of negative 1.50 and 1.50. And we're looking for the area that's in between. Now it says shade the region of the curve that represents the desired probability and label the appropriate values on the horizontal axis in the curves, and that's exactly what we did. The last part of this question is asking us to use the normal distribution tables, the z-scores, to find the desired probability. Another way of doing that is the calculator version, so I've shown you 2 different versions here. Now, using the table of z-scores, we want to find the probability that x is in between 70 and 100. And now since we converted those numbers into z-scores, we want to find, okay, the value or the probability that's in between negative 1.50 and 1.50. So what we have to do is, because we're looking at the tables, we need to find the probability of the z-score that's less than 1.50 minus the probability of the z-score that's less than negative 1.50. And in order to do that, we can go ahead and look at the table. So we want to find the probability where the z-score is less than 1.50. So looking at the positive z-scores, we have 1.5 and then 0. So this is 1.5, there's your 0. You scroll down here and you find that that particular probability is 0.9332. And then we also want to find the probability for negative 1.50. And if you scroll down here, you get the value of 0.0668. So now what we do is we go ahead, put in our number for the probability it's less than 1.50, which is 0.9332, and then subtract the probability of the z-score it's less than negative 1.50, which is 0.0668, and it gives you a desired probability of 0.8664. Now, if you use the calculator version, you would use normal CDF, where you have the lower limit of negative 1.50, the upper limit of 1.50, the mean of 0, and the standard deviation of 1, which would also give you the same desired probability of 0.8664. So all of these are going to be required on your exam. So if you use the table of z-scores, which will be provided for you, then you need to show this step. If you have your calculator, then you would show this step. But everything here is what's required of you to show on the exam. Okay, now this next question states that the claim that most adults would not erase all of their personal information online if they could. A software firm survey of 824 randomly selected adults showed that 46% of them would erase all of their personal information online if they could. So complete parts of the following. So it's not A and B, but it's all of these. Okay, we want to write the claim as a mathematical statement first. Now, since this is a proportion, the claim is stating that most adults would not erase all of their personal information online if they could. So there's no number associated with the claim. So therefore, the claim would state that P would equal 0.5 because you're talking about most adults. Now, writing the opposite of the claim, in other words, if the claim was false, what would be true? Then therefore, you would say that the opposite of the claim would be P, which is less than 0.5. So now what we're going to do is we're going to state the null hypothesis. So you're going to write down H subscript 0 colon P is equal to 0.5. So you need to make sure you include all of this information in the correct symbols. State the alternative hypothesis would then be the opposite of the claim. So the alternative hypothesis is equal to P, which is less than 0.5. And then we want to know what is the tail type. And therefore, since the alternative says it's less than, then therefore it's a left tail. The next example says that the claim states that the mean pulse rate in beats per minute of adult males is equal to 69.8 beats per minute. For a random sample of 181 adult males, the mean pulse rate is 71.6 beats per minute, and a standard deviation is 12.3 beats per minute. Now, completing these parts, we want to be able to write the claim as a mathematical statement. So again, the first sentence is the claim. So that's the numbers that you're looking for when you're writing the claim as a mathematical statement. And it says that the mean pulse rate of adult males is equal to 69.8. So therefore, the claim would then be mu, which is equal to 69.8 beats per minute. And then the opposite then would be, what's the opposite of equals? Well, that means it would not equal. So therefore, the mean, or mu, is not equal to 69.8 beats per minute. Now we're going to state the null hypothesis. So therefore, you're going to bring down your claim, and therefore the null would then be mu is equal to 69.8. Stating the alternative hypothesis, therefore you would have mu is not equal to 69.8. And then we want to find out what is the tail type. Now, since the alternative is not equals, then we would say that it's a two-tail. Next question. The claim states that the standard deviation of pulse rates of adult males is less than 13 beats per minute. And then for a random sample of 192 adult males, the pulse rates have a standard deviation of 11.6 beats per minute. And again, complete these parts. Now, the first sentence is the claim, so that's the value that you're looking for. The standard deviation of pulse rates of adult males is less than 13 beats per minute. So remember that the claim is always going to have the the claim would state that the standard deviation is equal to 13 beats per minute. And the opposite of the claim is either going to have the less than, the greater than, or the not equals. Now, since it says is less than, then the opposite of that claim would then be the standard deviation is less than 13 beats per minute. Now you want to state the null hypothesis. The null hypothesis always has the equality, so therefore the standard deviation, the population standard deviation is equal to 13 beats per minute. The alternative hypothesis would then be that the standard deviation is less than 13 beats per minute, and therefore that would be a left tail. So that should be a left tail. So let me correct that statement here. Okay, now this last question, it says that a data set speed dating includes like ratings of male dates made by the female dates. The summary statistics are n is equal to 181, the sample mean is 4.41, and the sample standard deviation is 1.86. And we're going to use a 1% significance level to test the claim the population mean of such ratings is less than 5. Now the hypothesis test to test this claim has the following null and the alternative hypothesis and tail type. So this is given. We have the null where the population mean is equal to 5.00, and the alternative is that the population mean is less than 5.00, and therefore we know it's a left tail. So what we want to do is we want to be able to sketch the appropriate distribution showing the area in the tails and the location of the critical values. Now, since we know it's a left tail, we're going to draw our bell curve, and then we're going to draw our left point here, and we can see that in the purple here that the significant level has an area of 0.01. And so the next step before we add anything else in this question is we want to be able to determine the critical value and then write it down on your sketch of the distribution. So once we find the critical value, then we're going to put that here. Now, the critical value is going to be t subscript alpha. That's going to equal t subscript 0.01. And we want to be able to find out what is that critical value. In order to do that, we also need to find out what is the degrees of freedom. The degrees of freedom is taking a value of n, which was 181, and then subtract 1, which gives us 180. So what we're going to do is we're going to go to the critical value chart. And so we note here that since we're talking about an area in one tail, we're looking at the significant level of 0.01. So we're looking at this column here. And then we're going to scroll down and then look for the value of 180 to your left. Okay, now since 180 isn't there, then 180 is closer to 200. And so therefore, you're going to go to the right over here, and this is your 0.01, and therefore, you're looking at a critical value of 2.345. And so therefore, our critical value then is negative 2.345. And the reason why it's negative is because it's the left tail. So you got to make sure it's negative. So now that we found our critical value, we placed it into our diagram. Now the next step is that we want to be able to write the appropriate test statistic formula. So you got to make sure you have the right formula what you're using. So that formula is written right here with the numbers in place, and determine the value of the test statistic. And then you're going to show the approximate location of the test statistic on your sketch of the distribution. So in our question, we know that the sample mean is 4.41. We know that the mean from our null hypothesis is equal to 5. We know that the sample standard deviation is 1.86, and the value of n is 181. Now, plugging everything into our formula, we would end up with a test statistic of negative 4.27. And then we want to make sure that this location is now placed in our diagram. So if you look at our diagram, we note that the test statistic in green here is to the left of the critical value, which is the critical value of negative 2.345, and the test statistic is negative 4.27. So the region to the left of the critical value, you would reject the null. The region to the right of the critical value is the fail to reject the null. So the next question says, do we reject or fail to reject the null hypothesis? Now our answer would then say, since the test statistic of negative 4.27 is to the left of the critical value of negative 2.345, then we would say that we reject the null. And then the final question would state that what is the conclusion for the claim? Now, since we reject the null, then we would say that there is sufficient evidence to support the claim that the population mean of such ratings is less than 5.